Okay, so in here minus b, so it will be 4. Okay, so we have come to this stage. So what you do is after this point, so just substitute here. We can't do anything about this one, the numerator part. So we can put this one. So 1, 2, 5, 6 times d dash squared, we have minus 4. So if you are finding any negative, you better put it inside the bracket. Okay. Similarly, this is 625 times negative 9. So I don't know. You have solved it. You can use the calculator. So you will get the denominator part something like around 1 negative. Okay, negative. Yeah, 10649 something a big number. It doesn't you know it's not a problem for us. Okay, let's do the sign through 3x plus 2y. Okay, so we have found we have get rid of the d and d dash in our denominator. So only thing is numerator there, still d dash and d is there. So how to solve this part is, okay, so I hope you have this negative just comes from here, this denominator, 1649. Okay, so I better put here. Okay, so okay, I will take the new window to show the last. Okay, so in here you can have so we can take our 2 in that RHS part. So I'll write this coefficient in one side. So what I'm going to do is I can multiply the 36d dash plus 25d is there. No? So I'm going to multiply by sine 3x plus 2y. It comes like 36d dash of sine 3x plus 2y. Also, we have 25d, which is also sine 3x plus 2y. I'm just cancelling the bracket, okay? So we can show you like this. Okay, so that's all we can do. So from this, see here, so what actually the d and d dash? Can you tell me? What actually the d and d dash we have arrived? I mean, in the definition case, we have taken d is equal to what? Actually, from the beginning of the solving process, what we take d as? Can you tell me? Go through your first step. There you will get the characteristic equation. So from the main equation, you will take the dd. So what do you? So let me see the answers. Only one answer. No, I'm not meaning the m. What is the actual definition? So from see here, you have taken like this, no? So from the daba cube x u over daba x cube or something, you have taken that d cube. So what is actually the d you have taken? You're actually taking d as a daba over daba x, isn't it? So that's what I'm asking. The initial point, we have taken d as a daba over daba x, d dash as a daba over daba x. Okay, so that we're gonna retransform this in that form. Okay, so only for this kind of questions. Okay, not always. So if it is third order and like this kind of comes, we can use that this kind of solving processes. So actually this is a little bit of away from our course, but it's better to have some knowledge. Okay, so see here 36 there. So what is d dash? D dash I'm going to transform daba over daba. So I'm just writing here. Okay, so it is kind of daba over daba y of sine 3x plus 2y. What is this? It's like a differential equation of this one, no? So if you differentiate this part with respect to y, x as a constant, what you'll get? What is a sine 3x plus 2y? Sine x differentiated will be cos, sorry, cos of 3x plus 2y times, we are differentiating with respect to y. So y terms also they are here. So times 2. Did you get that? Okay, so that's what we're gonna transform here for this part. Okay, so 36 there. For this part, I'm going to transform what is the dabba over of sine 3x plus 2y. So I'll get cos 3x plus 2y. Similarly, what do you think? This one, d will be dabba over dabba x, no? So dabba over dabba x of sine 3x plus 2y. So it will give you again cos 3x plus 2y times. So here we're going to check the x term. So this will be 3. Already 25 there. So we are transforming this part only. Okay. So 25 times 3 times cos. Okay. Cos 3x plus 2y. So now what will happen? Just write whatever. Like see both are cos. So you will have some simple number. So you may get something like 295 divided by. Don't worry about this. Constants. It may be something. This one you may get, yeah, same cos. Okay, cos 3x plus 2y. So this is our final answer. So this is one of the example for you to show you there are so many ways you can solve it. So in this situation, if you can't transform d and d dash with any of this, I mean, in the list of PI methods, you can retransform to our original things, and then you'll get something like this. So this is kind of the answer for this question. Okay. So I hope I have completed. So at last, this is only our PI, no? So you have to write what is our complete solution will be. That is equal to whatever you find CF plus PI, this PI. Okay. So this is the final answer. So one of the student asked that. So I have finished it. Okay. So just write down roughly so you can finish up later. Okay, let's begin our actual lecture here. We are in our chapter 3 still. Okay, I thought to finish today, but I will try. Okay, so we also have one more chapter, chapter 4, that is also regarding this one. But anyway, I need to finish this one. Chapter 3, I have finished section 1 that I also have sent you the module. This one will be section 2. But I'm not sure I can send you all the notes, but you better write with me all the things. Okay, I'm also writing. So so in the meantime, you can also write. Okay, so if I got any time more, so if it is possible only, I will send the note. Typed on note. Otherwise, that's all. Okay. So in the section number 2, we have in the last lecture also we have started our study of classification of second order PDE. So I have explained to you everything. So I'm just gonna roughly go through it. Okay. So fundamentally we have sorry. Okay. So our equation will be, I'm writing roughly. Okay, AUXX plus BUXY plus CUYY something D plus, which is equal to 0 is our main second order equation. So only thing is we have to keep in mind we also have the constant. This constant also function of the variable x comma y possibly, or otherwise constants. Okay, and this equation uh, U is a thing what you have to solve. Okay, so in here since of second order we are considering UXX. Okay, this is like a da bar square u over da bar x square. Here U is our dependent variable, x and y are the independent variables. So these all are we have seen already. So I'm just gonna go quickly to get our today's lecture. Okay, so there are three kind of types we can fundamentally divide our second order PDEs, which are hyperbolic in the sense we use for the wave equations, and then parabolic we told as a heat equation, also elliptic. So elliptic case for the Laplace equations. So you also can you also have derived some from this we have like a second order equations, like a quadratic equations. Okay, quadratic in the sense in our algebraic equation ax squared plus bx plus c is equal to 0. Like that way we're going to treat this one. Okay, they are discriminant delta. Okay, we also say this as a discriminant. Okay, this discriminant delta is equal to b squared minus 4ac. Okay, according to the sign of the delta, we can divide these types. So if the delta is greater than 0, we call this as a hyperbolic. Similarly, if it is delta is equal to 0, we call this as a parabolic kind of equation. And then delta less than 0, we call it as a elliptic equation. Okay, delta is less than 0 in the sense we may have some complex ideas. Okay. Okay, so we also have told you about the transformations of parameter, variable. Here we have the ux comma y. So now for some purposes and classification, we to get the canonical form of this equation, we can transform these xy terms into the u of psi x comma y, and then for the y variable we are transforming neta. Okay, zeta neta. Okay. Okay, we're gonna end our meeting soon, so you can join again. Okay, so in this sense, we also have used our vector calculus knowledge, where you have to check your Jacobian, where if it is not equal to 0 only, it is possible. Okay, so those also we have analyzed. So yeah, if you are transforming the xy variable into zeta neta, okay, we will have some since we have uxx, uxy, uyy, and again ux term there, uy terms there. Okay, also some constant there. All these things should be transformed into zeta neta again. Okay, there we have used our chain rule idea to since if you wanted to have x, first of all, you have to think about the zeta and zeta x. It's like a chain rule, isn't it? Again, that x also depend on u neta and neta x. Okay, in this sense, we have to transform our full equation A in here in terms of this zeta and neta. Okay, that's what we have seen. Okay, I told you to do the homework as to derive the last term. Okay, I hope you have done that as a homework, and I will give you the last part. Okay, so I guess after you substituting, okay, so I'll try to write it from here. So after you find ux and uy, sorry, is that, yeah, and then uxx, uxy, and uyy in terms of zeta and neta. Okay, zeta and neta variables, you will have a big kind of equations. But after you substitute these in our main equation, you will have for a terms for the uxx term, isn't it? So our equation actually auxx plus b uxy plus c uyy. Okay, and then all the other rest of the term we are only considering the second order. Okay, all the other terms we are taking as a pi. Pi may be given on x comma y comma u comma ux comma uy. Okay, all the first order and the dependent variable, independent variables, all these terms are we are taking as a function of pi. Okay, it's equal to 0 because our main thing is second order transformation. Okay, so only things I'm gonna transform uxx, uyy, uxy. Okay. Okay, let's see whether your answers are correct. I'm just writing what is uxx first of all. Okay, so I have explained you how to do that in the last class, so I'm not gonna go again that thing, but I'll give you this answer. Please check your answer whether it is correct or wrong. So I hope I have given you the uxx already. So I'm just writing u zeta neta times zeta x neta x plus u neta neta times neta x squared. Okay. And also we have u zeta zeta xx plus u neta neta xx. Okay. This is our terms of uxx. Okay. Again, let me substitute my uxy terms, okay, in terms of zeta and eta. Again, you will have zeta, zeta, zeta x, zeta y, plus check whether your answers are correct. Zeta, neta times, I'm just, after some simplification, you will arrive zeta x, neta y, plus neta x, zeta y. Okay. Plus, we also have term u neta neta, neta x neta y. Okay. There's one more term there. U neta zeta xy plus u neta neta xy. Okay. This much of terms we are having for the uxy. Okay. So if you done the things using the chain rule correctly, you will get there. So what about uyy terms? Okay. So these I gave you as homework. So check your answers whether you have reached the correct answer. So u zeta zeta again. Here zeta y square. Okay. Plus 2 times u zeta neta. Again zeta y neta y. Okay. And then u neta 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 y whole thing square. Okay. So we have some more terms. 2 terms u zeta zeta yy plus u neta neta yy. Okay. Also, we have a new term. This pi has been transformed into zeta. Okay. Another different one. Okay. Which is equal to 0. Okay. You have to know this pi dependent. This pi dependent. I told you this pi dependent x, y, u, ux, uy. Similarly, this pi dependent zeta, neta, u, zeta, u, neta. Okay, so that's the different things. All the other terms are we are taking under this pi. Okay, so check whether you have got this answer correctly. So let's take, I don't know, you are following the same numbers. So you just put the whatever the number you are following. Okay, so I'm taking this as a equation number 7. So is that correct? Is there anything wrong or anything? You can tell me. Okay. So okay. After this, okay, I'm gonna take the new window, but what I'm gonna do is for the see here, I'll take the color for you to understand. Okay, see here. In this term also you have u zeta zeta. In this term also you have zeta u zeta zeta. Here also u zeta zeta. So in terms of if you wanted to take u zeta zeta, outside, you will end up a zeta x squared, b zeta x zeta y, c zeta y squared, isn't it? So I told you to derive that one also. Okay, so that's what I'm going to take. Similarly, you also have different u zeta neta, u zeta neta, u zeta neta. All 3 terms having these variables, isn't it? So I'm going to take that variable out of the brackets. So if you, let's follow this one. So yeah. So if I take, u zeta zeta out, I will have the term a zeta x squared plus b, okay, zeta x zeta y plus c zeta y whole thing square. Okay, I'm only taking u zeta zeta as the common from all these equation. So okay, from the 7 I'm deriving this. So what about u zeta neta terms? Okay, you will have something like 2a zeta x neta x. Okay, so when you're writing also, you check your answers. You may have in your notes, but since I'm using new Windows, I couldn't, you know, see the things. But when you are writing, you can check whether we are doing correct or not. So here zeta y. Okay. Also 2c zeta y neta y. This is my second term. Again, third term, let me take neta. Okay. So if you take neta, you will have neta square x square plus b neta x neta y plus c neta y square. Okay. So what has happened is our earlier equations, equation number 1 has been transformed in, xy term transform into zeta neta, isn't it? Here everything has the form of zeta neta. Okay, so we have transformed. So whatever we also may have, we also have the pi also now. So using some, so let's, I think pi can be also change. No, it's not changing. Okay, let's keep like this. So zeta neta u zeta u neta. Okay. Okay, this is equal to 0. This is our equation number 8. So I'm just only taken these variable,